today we're gonna do experiment 6, reduction of sample size by quartering method and determination of specific gravity, water absorption, moisture content, and densities. Dry relative, saturated, apparent, book specific of quartz aggregates. So our objectives would be to determine the densities, moisture content, specific gravity, and water absorption of using the quartering method, and to be able to assess the outcomes that came from the experiment's data.
For the materials, we're going to be using 3 rectangular containers, a tape measure, a drying oven, coarse aggregates, and a mixing pan, and sieve number 4.
Gather the dimension of a rectangular container, its length, width, and height.
Bro, ano man siya? 2x2 mag-awag.
Now we will weigh the rectangular containers with a digital scale.
We will now collect the coarse aggregates using the quartering method, where we would put the coarse aggregates in a flat surface and flatten it uniformly. And after that, we will divide it into 4 equal quarters and then remove the diagonally opposite sections.
So after that, we're gonna weigh the dry coarse aggregate.
So after weighing the coarse aggregates, we're going to wash the coarse aggregates to remove the dust.
After washing, we are gonna weigh the coarse aggregates.
Now we're going to submerge the coarse aggregates in the water.
Submerge siya, wala? Or kailangan pag-water ka man? Sige na, sabi.
So currently, it's the next day and we're gonna weigh the samples in water.
By 782.3. Now we'll dry our samples using a non-absorbent cloth.
Sir, gel ba? Sumbong ka diya may kapasay.
Ito no, pato na zero.
Gusto ko naman siya ang tawag. Sir, may nakasalit sa wall. Nakasalit pala. Sir, balik ka.
So after drying the coarse aggregates, we're going to place them in the drying oven for 24 hours.
Facebook lang na. Di ba siya sa layabo?
Hello everyone, day 3, it's been 24 hours and we will get our sample out in the oven and wait for it to cool down. Boy!
So after 2 hours, we're going to weigh our sample.
In this experiment, we tested the physical properties of coarse aggregate such as moisture content, water absorption, density, and specific gravity using the quartering method. The quartering method helped us reduce the sample size in a way that still gave us fair and balanced sample. After soaking the aggregate in water and following the property weighing steps, we found that the average water absorption and moisture content were both 3.75%. This means the aggregate can hold some water, which is important to know when mixing concrete because it affects how much water should be added. The densities we measured were also quite consistent, with the average drying density being around 1,556.47 kg per meter cube and bulk density at 1,605.46 kg per meter cube. This result shows that the aggregates are packed well and don't have a lot of empty space in between. We also measured 3 types of specific gravity: dry, saturated, and apparent. The average values were 2.3, 2.39, and 2.52 respectively. These numbers tell us about the internal structure of the aggregate. The higher apparent specific gravity shows that some pores inside the aggregate do not absorb, while the lower dry specific gravity includes these pores. Trial 3 has the highest water absorption and specific gravity, which may means that some have more pores or was more textured than the other. Overall, the results were close across 3 trials, which means our methods were consistent and the aggregate we tested were fair, uniform, and equal. Based on the result, the test aggregate should be rejected for structural use. The dry and saturated specific gravity values were below the DPWH standard of 2.5 to 3.0. The average water absorption of 3.75% exceed the 2% limit, indicating high porosity. Although the bulk density were within the ASTM range, the overall quality does not meet required standard for durable concrete. This experiment is important in civil engineering that ensures that only quality aggregate are used in construction. Testing helps prevent structural issues caused by poor material, ensuring strength, durability, and long-term performance of concrete in real-world applications.